the circle.
Or that works too.
Yeah, that too.
X squared plus y squared equals 25 is a circle. Do I know any information about this circle?
No,
Radius of y. No, the point is at 0, 0. Center.
Center's at 0, 0. Radius of y. Graph it.
Graph it.
Graph it by hand. Make a nice little pretty picture.
Graph it by hand. How do I know the point 3, negative 4 is on the circle? Yeah, yeah, right. 3, this is a x length of 3, this would be 4, and we know the radius is 5. Does that make sense? So I just picked a random point on the circle, and I drew a little radius, and I drew a little tangent line there. Could I figure out the slope of this radius line segment? And how can I do that? Don't need it for the slope of the radius. Don't need that either. I don't need any derivatives in order to find the slope of this line segment. Don't even need that, because what do I need in order to figure out slope of a line segment or slope of a line? And how did you get that so mathematically quickly? Rate of change.
How did you figure out? Like, I only see one point. Are you just saying it's these points?
0, 0.
Yeah, you have 2 points. Does that make sense, Anna? You do have the point for this circle. You do have the point 0, 0. Okay? So if I wanted the slope of this little radius, it would be, say it again for me, Chris.
Negative 4 over 3.
Negative 4 minus 0 over 3 minus 0 would equal negative 4 over 3. Do we agree with that? Could I, with given information, figure out the equation of the normal line?
Yes.
At this point?
Yes.
How could I do that? Yeah, well, what do I have the slope of? What's this the slope of? Yeah, which is the what in this case? That little radius is the what at this point? It is perpendicular to the what? Which makes it the what? Yeah, this is the normal line. Does that make sense, you guys? That little line segment would be perpendicular to the tangent line, which means it is the normal line. At this point, if we just solve for the slope of this line segment and we have a point, how could we figure out the equation for the normal line?
We have to find the slope, which is the opposite.
Why, I want the equation of this black line. Do I have enough information to figure out the equation of this black line?
Yeah.
Yeah, I have the point, and this is the slope of it. I just figured it out. So what's the equation for that black line segment, or that normal line?
Y plus 4.
Equals negative 4 over 3 times x minus.
Normal line. Y plus 4 equals negative 4/3 x minus 3. Do we agree with that? We do.
Yes.
Yeah, sure. Okay, good. Okay, do I have enough information to figure out the equation for the tangent line?
Yes.
Well, do I have a point for this blue tangent line? What's the point? Do I have a slope? 3/4. Where are we making this up? Are we making up numbers now? Opposite sign, flip the numbers. Perpendicular lines have opposite reciprocal slopes. This -4/3 would be +4/3 and flip it. The slope is 3/4 with a point and a slope. Could I figure out the equation of the tangent line, Stella? What is it? Okay. Does that make sense?
Yep.
Do we agree with it? Great, we actually just got a normal line and a tangent line using no calculus. Lame. Let's use some calculus now. X squared plus y squared equals 25. This is not in our nice clean y equals form. So we haven't done anything like this. So what implicit differentiation means is that it's not in y equals form. It's a big fancy word for taking the derivative when it's not in y equals form. Okay? But you follow the same rules. You take the derivative of both sides. You d dx both sides. And if you d dx this side, since there's a plus, you can kind of just d dx everything. And then you d dx this side. Does that make sense, you guys?
Yes.
When I take the derivative, I'm going to take the derivative of both sides of the equation, or take the derivative of everything. It's not a product rule, so it's just, I can do each individual derivative. Ask your question.
How do you know that some of those two derivatives equal the derivative of
Well, this was the equation. The only thing I did was I took the derivative of both sides. Like when you have something like this, y equals x squared plus 5. What we've been doing really is taking the derivative of both sides, d dx, d dx, and then there's a plus sign, so you can do this after. We take the derivative of both sides of the equation. What is dy dx? Y prime. That is what I'm solving for. That's dy dx, or y prime. What is d dx of x squared? Yeah. Well, here's how we do it. This is like a chain rule problem. You go knocking at the door. Who's home? I don't know yet. I have to do the 2. Bring the 2 down. Leave what's inside alone. Raise to 1. Times d dx of what's inside, which is x. And what is dx dx? Yeah, so we just haven't been writing it. Does that make sense, you guys? You can treat that as a chain rule. Does that make sense, you guys? I can't look to see what's inside yet. I have to do the power rule times the derivative of x.